Hello students, I am Raghunanda working as an assistant professor of physics. Today in this class, we are going to deduce Wien's distribution law and Rayleigh-Jean's law from Planck's law of radiations. Students, as you all know, before Planck, there are many scientists, leading scientists at that time, they tried to uh, explain the black body radiation spectrum with the help of classical laws, or we can say that the laws so far known at that time. And one of them is Wien. So William Wien in 1893 gave a simple relation between the wavelength for which the intensity is maximum and the absolute temperature, and he showed that the wavelength for which the intensity is maximum is inversely varies with the temperature. Wien also showed that the maximum energy Em is directly proportional to the fifth power of the temperature. By combining these two equations, he gave an expression for the emissive power is equal to some constant C into lambda to the power of minus 5 into some function of lambda into T. By comparing the black body radiation spectrum with the known Maxwell's velocity distribution curve, he assumed that this function, which is the function of lambda into T, is of exponential form, and he gave that f lambda t is equal to a into e to the power of minus a divided by lambda t. By putting this value of f lambda t in this equation, the emissive power would be equal to k, that is some constant, into lambda to the power of minus 5 e to the power of minus a divided by lambda t. Here the constants k and a are the adjustable constants, and the expression for the energy density according to Wien is E lambda d lambda is equal to some constant k lambda to the power of minus 5 e to the power of minus a divided by lambda t d lambda. But it is observed that this Wien's law holds good only for the smaller wavelength region of the black body radiation spectrum, and when it is extended to the longer wavelength region, it failed to fit with the experimental curve. And it is also observed that the Planck's law of radiation, which is called as the complete law of radiation, can be reduced to Wien's law at smaller wavelengths. Hence, Wien's law can be deduced from Planck's law. Now let us see how it is done. So let us consider the Planck's radiation equation, in which if we take lambda to be very small than the term hc by kt, at that time this exponential term will be very large compared to 1. Hence we can ignore this term 1. At that time this equation will become E lambda d lambda is equal to 8 pi hc divided by lambda to the power 5 into e to the power of minus hc by lambda kt d lambda. By putting 8 pi hc is equal to k and hc by k is equal to a, so we are going to obtain the Wien's distribution law. So that is how Wien's distribution law can be obtained from Planck's law of radiation. The other scientists who tried to give an explanation for the black body radiation spectrum are Rayleigh and Jeans. Rayleigh and Jeans, they have given a formula for distribution of energy in the black body radiation based on the principle of equipartition of energy for all possible modes of standing electromagnetic waves. So they considered the electromagnetic radiations as the standing waves in the cubical chamber. The equation for the energy density obtained by them is given by E lambda d lambda is equal to 8 pi kt divided by lambda to the power of 4 d lambda, or in terms of frequency it is given by E nu d nu is equal to 8 pi h nu square kt divided by c cube d nu. This equation agrees very well with the experimental measurements for long wavelengths and failed at the shorter wavelength. So this curve shows that, this line shows that it very well fits with the experimental curve at longer wavelength region, but failed to fit with the experimental curve at shorter wavelength regions. It predicts an energy output that diverges towards infinity as wavelength grows smaller. The failure at short wavelengths has become known as the ultraviolet catastrophe. That is, at ultraviolet region, the energy becomes infinite, isn't it? So that is the flaw that is observed in the Rayleigh's law. And again, the Planck's law can be reduced to Rayleigh's law at longer wavelength regions. So at that time, this exponential quantity will be expanded as 1 plus hc by k lambda kt plus h square c square lambda square k square t square, so on and so forth, because e to the power of x is expanded as 1 plus x square, so on and so forth. And as the lambda value is large, hence the second, third, fourth terms can be neglected because lambda comes in the denominator. Hence the equation will get reduced to, or else we can say that this exponential term will get reduced to 1 plus hc by lambda kt. By putting this in this equation, what we are going to get? We are going to get this equation, which is same as that of the Rayleigh's formula. So that is how we can deduce the Wien's distribution law as well as the Rayleigh's law from Planck's law. Thank you.